Okay, we're going to start with 6 and 7 just because you guys seem the most concerned about these. This is in vertex form, and I will leave these clues up on the board. It reminds me up here that if it's in vertex form, my vertex is HK. Well, what is H and what is K? It'll give you a hint over here. So for this particular one, my H and K is 2, -5. So that's my vertex. That's one point that I can go and graph. Over 2 and down 5. I can also make that dots through it because I know that's going to be my axis of symmetry. So if you're like, how do I graph things from vertex form? Step number 1, find your vertex and dot your axis of symmetry. The next thing that I would recommend you do, I think sometimes we can use that. Oh, actually, that's not true. I don't want to lie. Try to find a point to the left or to the right of this, because then I can see where my parabola is headed. So I usually will use 0. Unless it's really far away, I'm going to pick x equals 0. So I'm coming over, I'm going to find f of 0. This will be the y-intercept. But for this problem, it's also pretty close. It's only 2 away. So I've got 1/4, 0 minus 2 squared minus 5. And I'm just going to solve that side. This is going to help me find my y-axis, which my y-intercept, which really doesn't matter. But again, I'm trying to find something that's close to my vertex. So 0 minus 2 is -2. -2 squared is 4. What's 1/4 of 4? 1. And you can plug it into your calculator. So another point that's on this graph is going to be 0, -4. This is my x. This is my y. I'm going to make it blue. 0, 1, 2, 3, 4. Now that I've got 2 points, I can reflect that blue one, that 0, 4, over the axis of symmetry. So if it's 2 away on the left, I'm going to reflect it 2 away on the right. And here's my parabola. And I like that it's really wide because this is a vertical shrink. This distance has shrunk, so it should be pretty wide. If it's a negative here, it should have flipped upside down, which none of them are negative so far. Okay, now that you're looking at it, if I gave you a whole different vertex problem, could you follow those steps, or is there a part that's kind of confusing? Are you guys all okay that the vertex is a +2 and a -5? Even though that says minus? So that if that's confusing, if you might mess up the vertex, write yourself a note on your note card right there. That might be something you need to remind yourself. Opposite, same, or I don't know. Okay, you guys are all good with that one? -b over 2a, probably because we've been applying. We'll come back and do it anyway, but let's do number 7 next. All right, this one is in factored form. When you're in factored form, these are your zeros. Matt, what are the zeros? What does that even mean? The x-intercepts. And the way you find, there's a couple shortcuts. This is 5, this is -1. But if you don't know what that even is talking about, you set them equal to 0. Setting it equal to 0 is making sure your y is 0. I am creating this situation. I'm saying I want y to be 0. And then when I solve, I'm finding that my x-intercept is 5. And my other one, so again, I'm creating this situation. My other one's -1. So if when I taught this, if it's sunk in a little bit, you don't have to set it equal to 0 and subtract it or add it. You just know it's the opposite. But some of us aren't even there yet. We need to go through these steps to find the zeros. Okay, I found them. The next thing that we need to find is the vertex, right? Because I don't know, is it up here? Is it down here? I know it's in between these two. Okay, so next, find your vertex. For these ones, you find it by doing P plus Q divided by 2. What's P and what's Q? So step number 1, find your zeros. Step number 2, find your axis of symmetry, which is P plus Q divided by 2. Which I already knew that. I can tell that 2 is right. I can tell that. But I need it to find my y. I don't know if you guys remember the day we were going through it. Jetta was like, why do I need to do the math if I can just see? So you don't have to do the math. You could just see that it's a 2. But I do need the 2 to plug it back in for my x. By doing this, I'm finding f of 2. I'm saying to this problem, if x is 2, what is y? That's the question that I'm asking this equation. And this is how it answers. So 2 minus 3, oh, never mind. 2 minus 5, 2 plus 1. A lot of you punch into your calculators, but. All right, so f of 2, I just found another ordered pair. 2, negative 3. And now I can create my parabola. It's supposed to be roundy. I'm not good at making them rounded. I think this one's the most steps. Just like when we're solving from factored form, it's the most steps that we have to go through. Find the zeros. Find your axis of symmetry. Solve for your vertex. We need to know the y. If I was like, it was kind of hazy, but I kind of knew what I was doing, that's what I would write down. Okay, any other requests? Again, we'll do all of them. Any of you want to see right now? Okay, let's go back up to number 1. True or false? This is shifted 3 units up. So anytime we talk about shifting, we are comparing everything to the parent function. And we haven't talked about her for a while, but she goes through the origin, and she's a perfect U. Yep, this is y equals x squared. She's super boring, but she's the parent. She's steady. She's the same all the time. So when I say what is happening to this quadratic, it's because there's all kinds of fancy stuff happening. Okay, this is in vertex form. So hopefully you now can see that my vertex would be negative 3, negative 5. If that's confusing you, I hope you wrote something on your note card about it. So from the parent function, negative 3, negative 5, she shifted left and down, not up. So this is false. Yeah? Okay. Matching. I wish that these had a reflection over the y-axis, because I think that's also very important to notice, but it doesn't even ask you about it. So here again, if you know where the vertex went, you can answer, you can pick A, B, C, or D. You just need to know where the vertex went. It started at 0, 0, parent function, and it's moving. So hopefully now we've done 3 like this. This is the third one. The vertex for this guy is 1, negative 7. So from the parent function, it went to the right 1 and down 7. To the right 1, down 7. From the vertex. That's all I need to know about it. So we might skip down to number 4. It is also in vertex form. It's kind of weird because it doesn't have a K, right? There was nothing there. Plus 0, they make it go away. So Olivia, on this one, what is the vertex going to be then? This is the tricky part. Yes. So from the parent function, it went left 3. So that one shifted to the left. It didn't go up or down, though. Because this was still a 0, it didn't shift up or down. Okay, number 3 is in standard form, and it doesn't have a b value. How do I find the vertex from standard form? This was like Monday, Tuesday. This was totally the lessons we did this week. Ian, how do I find the vertex from standard form? Like the maximum, the minimum. How did we start doing that? Not sure? Sarah? Mm-hmm. If you're in standard form, this is how you start to find the vertex. Just be careful. There's no b value. There's not an x. It must have been 0, x. So negative 0, I feel weird writing that, but whatever. Negative 0 over 2 times a, it's just going to be 0. So it didn't shift left or right. That's what that's telling me. This did not shift left or right. It just went up or down. So there's a couple things. This is the, well, maybe that doesn't matter. So let's plug 0 back in. Let's find f of 0. Negative 5, 0 squared plus 11. What's 0 squared? 0 is such an interesting number. 0 times negative 5 is 0. 0 plus 11. So this is our ordered pair. This is our vertex. From the parent function, keep thinking about that parent function. She's at 0, 0. It went left and right, not at all, but it shifted up 11. You are allowed to use a calculator on the test. That makes me a little bit nervous for these ones because I think there's some people that will use this as a crutch. I need to see your work on these. I need to see you finding these pots because you could just put it on your calculator and whoop, right? But if you get so stuck on this test that you're going to fail it if you don't use your resources, like maybe you're saying to yourself, is this a negative one or a positive one? I don't remember. Like I need to remember that. Graph it. Put it in your graphing calculator. Why don't you want to go there? Oh, it's opening. Go double check what it looks like. Again, you're high schoolers, so maybe you'll totally just use it as a crutch and leave this test with an A and not knowing how to do any of it by yourself. But if I am not sure if it goes left or right, I'm going to double check. I'm going to double check on my graphing calculator. Okay, I'm not going to take the time to do it. I think you all know how to graph it. The only thing I would recommend, though, is some people have fiddled around on the graphing calculators with, they want to see a different window view. So at the beginning of the day tomorrow, we'll reset the calculators so that they're cleared off. So if you graph it, you should be able to see it. Okay, let's look at number 5 now. This one's in standard form. It's kind of like number 3 up there. So Sarah, if I'm in standard form and I want to find the vertex, what do I do? Yes, I hope this is starting to sink in. Today's the day. Negative b over 2a. This is my a, this is my b, this is my c. So negative b over 2a. That's my axis of symmetry. Allie, once I have negative b over 2a, how do I find the y value? Like how far up or down my vertex is? Plug it in for x. Find f of 2. 3 times 2 squared minus 12 times 2 plus 4. My hope today is you'll start to see the patterns. Even though the problems look way different, this is what we just did on number 3. Number 6 was the same thing we did on number 1, 2, and 4. It was all that same idea. Where is my vertex going? How am I finding my vertex? Where is the vertex? How am I finding a vertex? Okay, so 2 squared is 4. 4 times 3 is 12. You're welcome to use your calculators on this. Okay, so my ordered pair is 2, negative 8. what do I need to find next? Just like any of these other graphing problems. Well, kind of. I don't think this one's easy. You could try to factor it and see if you can find your zeros. I heard you say it. What did you say? Another point. There is a shortcut on these ones. What is that in standard form? Your y-intercept. It's not like that on everything, so I'd be careful, but this is your y-intercept. And then we can reflect it. Whoa. If that feels like something that you don't know how to memorize, do the same thing that we did on this one, where we plugged a 0 in for x. Like you can do that for more than one equation. Plug a 0 in. What's 3 times 0 squared? 0. What's 12 times 0? 0. So we've got 0 plus 0 plus 4. You're still going to find your y-intercept. But if it's too much to memorize that that is your y-intercept, find it a different way. Okay, let's look at the top. Any questions on these? Could you do some more that are a little bit different? Can you figure out the shifts by finding the vertex? Okay, this one's giving it to you. This is a little tricky. This is a little tricky. Negative b over 2a. Hopefully you're seeing the patterns. Now we're taking those same equations and we're graphing them. All right, Bradley, what do I do to rewrite the function into standard form?
Start out by separating it and FOIL.
Yes. We've been doing so many crazy things. I think we forget, just please do your order of operations. Do not add too soon. Don't distribute too soon. The only mistakes I'm seeing on this is people are adding at the wrong place and distributing at the wrong place. So I like what Bradley said. Let's expand it out. Plus 11. Please don't add the 11 until the very end. This add 11 is your addition subtraction. He's the caboose. And this 1/2 is multiplication. This is parentheses and exponents. We want to do our parentheses and exponents before I distribute. Some kids were distributing now. It's not time to do that yet. You'll get the wrong answer. So first, outside, inside, last. Combine your like terms. I'm just going to erase them. Now what do I do? Should I add the 11 now? No, it is not his turn. He has to wait until the end of order of operations. Somebody decided that, and this is why, because you'll get a different answer. So we do need to distribute here. Now you can add your 11. So if I were going to do something in my brain, I would think order of operations. A what? It's supposed to be a 3 because it's a negative?
You have it as a negative bx. You put a plus because it's a half.
Here? I don't know.
Because in the problem it's half and then negative. So should it be a negative? That times the negative.
Now I'm nervous. Okay, half of 1/2 x, half of negative 8 is negative 4, half of 16 is a positive 8.
Because I thought 3.
So somehow you had maybe, I'm guessing, I don't know, a negative times a negative is a positive 16. Maybe you had a negative 16 right there.
Because what I usually do is, because I, like at the very beginning when you like blow out and then you like distribute, I usually do like the 1/2 like the first.
Before? Then don't do that anymore. Order of operations says we have to do our exponents first in order for us all to get the same answer. So if you're distributing your 1/2 too soon, this is butting in line. Your multiplication and division is butting in line. It might seem confusing because we are multiplying here. We're multiplying here because of the exponent, though. Okay. Well, I'm not sure what happened on that one then. We'd have to go look at it. Camilla. Sorry, you're sleeping again. This is your nap time. Okay. Rewrite the function completing the square. I think this was the most missed problem on that last test that we did. And I've been trying to think of a different way to explain it that maybe will make the steps easier to understand. I don't know, but we're trying to make it look like this guy. So we need a perfect square trinomial, and it's not. If you try to factor this out and find two things that multiply to be -8, and these have to be exactly the same, it just doesn't work. Like, we have to manipulate this equation to make it work. So if you remember, the first thing I asked you to do or suggested is move this guy out of the way for a minute. He's not the right number. He's not the right number to make this work. So that was my suggestion. Add him to both sides. We'll do it properly. We're not going to be mean to him, but he just needs to be out of the way for a minute. Since we are doing some type of factoring, people really want to use this x. So let's practice using it. That's all I know. Right? But I do know that I'm trying to create a perfect square trinomial. So these have to be the same, and they have to add to be 12. There's only one option there. 6 and 6. Can you all see that? So this is a new way than I taught you before. This is different. But on everyone's test who was not getting it right, they all had this x. They really wanted it to work. So let's make it work. This has to be 6 and 6. If that is 6 and 6, what does that have to be? 36. Do I have a 36 here? It's empty. It's very empty. So from here, once you figure out these two mystery values, in order to make this equation true, we've got to put the 36 over there. Yes?
Is x the same thing as like b over 2 squared?
Yes. The way I taught it before, I told you to take the b and divide it in half. Ta-da! And then I told you to square it. Ta-da! So if you like this, if this works with your brain better, try that. I don't know. All right, so from here, instead of y plus 8 plus 36. That sounds angry. Just a minute. Oh, I'm recording. Okay. Is everyone okay that this just happened right here? Okay, this is another place where there's some confusion. So this and this are the same. Do you agree that this is this? 36, 12, like it's all, okay, so I'm going to now use my little factoring because everyone really likes that. X plus 6 times x plus 6. So it's almost into factored form. I just need to bring the k back to where it belongs. For this one, it's a plus 44, so I would have to minus 44. If you, like the previous problem where we FOILed and then we added, if you do that, you should end up back at your original problem. You can check your answers on these. Okay, I don't know if this is better or not, but I thought I should give it a try. I'd try to come up with a better way to explain completing the square. So this is your final answer. Yes? This 12? I put it down here because this is A, B, and we didn't have a C. We needed to figure out what C was. All we know was B. And because we're trying to create a perfect square trinomial, I know these have to be the exact same number. And there's only going to be one option. If this is a -12, this would be -6 and -6. If this is a 10, it would be 5 and 5. And then I square it to get my top one. What if it's what? If it's an odd, it won't be an odd number. You would just do the decimals, though. 5 1/2 and 5 1/2. You would put that there. You would square it and put it. So I think we doctor them so they're even. But if they're not, you just use decimals. Okay. True or false? It's considered vertex form. Oh, yeah. Question? Wouldn't the 12 be negative? 12 divided by 2 is... Okay. I think you're trying to find it a different way. If you want to find the vertex not completing the square, if you want to use it doing negative b over 2a, negative 12 over 2 times 1. Okay. Vertex form says x minus h. So if I do x minus negative 6, that's why it's a positive. So again, if you're using negative b over 2a to find the vertex and you're not using completing the square, you should still get the same answer. Then you would plug that back in and it would tell you you're negative 44. Okay. All right, is it considered vertex form? Yes. Is this a quadratic function? What does it take to be quadratic instead of linear? Your x needs to be to the power of 2. So this one is linear because the x is not to the power of 2. So it's not a quadratic function. That is linear. Quadratic functions will have x to the power of 2. Or if I FOIL this, it will create x to the power of 2. How are we doing on time? I don't know, we need to hurry. Find the quadratic equation given the x-intercepts. I don't know if the one on your test is multiple choice. If it is, it's nice because you find A and hopefully it matches with one of them. I don't know. So I'm going to use this equation. It's a factored form. Yeah.
How did you know that it was a factored form?
If they're going to give me my x-intercepts, P and Q, that's the only equation that even has x-intercepts in it. This one has a vertex. This one's got like the y-intercept. This is the only one that has them as part of the equation. That's a good question. So my y is 117. I don't know my a. So when I go to solve this through, I think it's 117a equals 117, yeah? And so when I find a, it's 1. So it can't be this guy, and it can't be this guy. Those are half and 2. It's either B or C. I didn't finish it, but a equals 1. Okay, a equals 1 here, a equals 1 here. Think about when we graphed this a minute ago. How did we find the vertex? So again, if you can see the connections between all these different ways, it's the same problems over and over and over. So P plus Q divided by 2, that's going to give me this value. So it's either going to be one or the other. Our P and our Q is negative 1, plus 3, and 2 divided by 2 is 1. So which one is it? Which one shows a positive 1 for your axis of symmetry?
You skipped 12.
I skipped 12. Oh, sorry, 12. Okay, 12 is the easier of the two, unless you try to use it P and Q. It passes through a point, and this is a vertex. How did I know it was H and K? Because it told me it was the vertex, and we call vertexes H and K. That's their special name. So same idea. I'm going to plug them in. I'm going to find A, and then hopefully it'll eliminate some of these options. But I'm plugging it into standard form. Oh my gosh, my brain. X minus H squared plus K. These will be on the board. You don't have to necessarily memorize them. So my y is 7. I don't know my a. My x is 1. My h is 2. My k is 5. 1 minus 2 is 1. 1 squared is 1. This is where I keep messing up, though. I keep wanting to add those together, and it gives me the wrong answer, if you were wondering. So don't add these. Just get it out of the way. So my a equals 2. It's not this one. It's not this one. Oh, I got to do one more step. It tells me my vertex is 2, 5. Does 2, 5 match up with this, or does 2, 5 match up with this? If you are no longer fooled by this little deal, you'll know that it's B. 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 Oh, I don't have enough time. Which one of these? Piecewise functions? Negative b over 2a. You guys can do that one. This one's funny. Well, it's not funny. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. I know. I think if you all can set this one up, you can solve it. This is how you set this one up. So if you remember from this one, we're going to solve for either length or width. It doesn't matter. We're going to substitute it in this guy and create a quadratic. I can go over this one tomorrow first thing if you guys want. So I really only have time to do one more. Which one do you guys want me to do? Piecewise? 17? Where is it? Oh, it's on the next page. All right. Number 1, make your domain dots. That is my suggestion. And at 3. Oh. I don't know if it's like this on yours, but my 2 is like super dark, so I keep thinking it's the origin. All right, what does it look like? This is linear, so it's going to be some type of a diagonal line. This is a quadratic, and this is a horizontal line. I like to start with the horizontal lines because they're dang easy. So 1, 2, 3, 4, 5, 6, 7. I don't even know if I counted that right. And then I'm going to check here. It's greater than or equal to. That is worth a point. Your closed circle is worth a point. This is a 6-point problem. Do I see your domain dots? Do I see your closed circles? Does your pictures look like what they're supposed to? All right. If this is x plus 4, if you don't remember what that looks like, put it in your graph. Oh, it's a horizontal shift 4 to the left. 1, 2, 3, 4. I'm not supposed to be able to see it over here. That's okay for a minute. It's okay for a minute. Looking here, this should be equal to, so it's going to be closed here. And I don't know where it hits it, but it's going to be open there. Just get rid of this part. I shouldn't be able to see it. Still a parabola. It shifted 4 to the left. This last one, this is a y-intercept of 9. Oh, I'm not supposed to be able to see this one right here. Okay, I'm going to do it really light with my pencil. Rise 3, run 1. Rise 3, what? 1, 2, 3, run 1. This is where you should start being able to see it. And then just erase that. Okay, I will finish the video, and so if you need to look at them, they'll be online. I think you guys were good. There's only 2 problems on the practice, though, for this, the cow enclosures, the sheep enclosures. So let's review how to do it. We need to set up something that has to do with the perimeter, and then we are always using this exact same area formula. This one is not changing. It's the same for all the problems. This is the one that changes depending on the picture, and this is the most complicated picture we've seen. So I don't know if you guys heard Mallory ask, like, is each one of these a length? I'm assuming that it's length, 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 length. So I've got 8 of these, and I've got 4 of the widths, and that's where my equation came from, is how many of each of them. So then from there, I need to solve for either length or width. I don't think it matters. It looks like they both go into the 16. So I am frozen. I don't even know how that got frozen. -8. If you did this earlier and you solved for W, do not erase anything. It's another good option. It's fine. Yes? 1, 2, 3, 4. So if those were the fencing and the width was 10 feet, I would need it 10 feet, 20 feet, 30 feet, 40 feet. Okay, so I'm going to solve for W. Again, I can't emphasize, if you solve for length, please don't erase your work. Our answers will merge here in a minute. So width for this particular fence with 160 feet of fencing, the width will be 40 minus 2 times the length. That's how math works. Certain things have to be true. Now that I have isolated the W, I can use substitution into the other equation. The reason why I'm doing that is I have to create a quadratic equation. Otherwise, I don't know how to find the maximum area. I only know how to do that from a quadratic. So I write down the length. Instead of W, I'm going to write my width that I found. I'm going to write this piece of an equation that is true for this fencing. It sounds like a science argument. Okay, I'm going to distribute the L through. Now I have my quadratic. So again, I think the whole question that I want you to keep asking yourself is, yes, you can do this. You guys flew through these problems. Is it retaining? Are you going to be able to remember how to do it tomorrow when you see it? Okay, that's the question. And if not, write something on your note card. Okay, the one thing I am going to do, I'm going to rewrite it in standard form. So that when I do negative b over 2a, my a is where it's supposed to be, and my b is where it's supposed to be. There's a lot of b's. So the question says, I can't see it, what is the maximum length and width so that your sheeps will have the biggest area? That's what we're trying to find out now. It's going to go like this. So we're trying to find the vertex. How do you find the vertex from standard form? Negative b over 2a is the first part of it. So negative b here is negative 40. 2 times a is 2 times negative 2. So what did I just find? 10. What is that? Is it the area? Is it the length? Is it the number of sheep? Is it the width? Whatever you have right here. So normally when we do negative b over 2a, I say this is your x value of your vertex, right? And we would normally have x's in here. So for this one, we have to think a little bit more, whatever that variable is. So my length, the maximum length is 10. Well, they want all of the dimensions. So in order to find the width, I'm going to come back to this equation. It's the only one that has it has all the things that I need. This one's got 3 variables, so I wouldn't use that one. 8 times my length. I know my lengths are 10 meters or feet or whatever this is. So then I can solve. I can solve for W. So the hardest part, I think, was that setting up the length and the width thing. That was kind of confusing. So subtract your 80, divide by 4. Is it 20? Did anybody get this answer yet? So the answer to the question, what are the dimensions that will maximize the area? 20 by 10. My width should be 20, my length should be 10. It will use all of my fencing, and the animals will have the most area possible. Okay, and I am videoing this, so if I start going too fast, pull up the video tonight. I'll have it on Canvas. Watch it and slow it down where you need me to slow down. Okay, I had not done number 16 yet, so let's look at 16. What's the first thing you do that I suggested when you see piecewise functions? Draw your domain dots. We only have one set here. It's at -3. I give you guys points for all these things, by the way. So some of these piecewise function problems are worth 6 points. The next thing I want you to do is, what does this look like? Well, this is going to be a parabola, and this is going to be some type of a diagonal line. And then we'll go and put those pieces. So if you don't remember what this looks like, put it in your calculator. Just type that in and push graph. Oh, that's a parabola with a horizontal shift of 5 to the left. Well, now I can do it. 1, 2, 3, 4, 5. It's a basic parabola. Here's where you get another point. For the parabola, x is less than -3. That is worth a point. That open circle. Okay, the next piece is going to be some type of a diagonal line. This is the y-intercept. This is my slope. Rise 2, run 1. Rise 2, run 1. I need to go in the other direction. So here's what the line's going to look like. This is also worth a point. You should be able to see this line where x is greater than or equal to -3. So when I go to grade this, I'm giving you a point for the parabola. I want to see that it goes where it's supposed to, the proper shift, right? Open circle and closed circles worth points. So this would be a 4-point problem. All right. Oh, I skipped this one. I think I did all the ones on the next page. Oh, I did not. Okay, let's do 18 and 19, and we'll go back into the other ones. Hope this is fresh in your memory. Average rate of change. F of B minus F of A over B minus A. Like, hopefully it's in there. All right, my A and my B, let's label them. I like to start with the denominator, 4 minus 1. I might only do one of these, actually. I don't know. We feel so smart. We feel successful. Now we go and do the little bit harder part. I'm going to start calling on some of you. You're going to fall asleep on me. Emma, what do I do now? One of the what? Oh, the functions, yes. Let's do f of b, which in this case, the b is of 4. What do I do with that for, Emma? Plug it into all my x's. Did you guys already do this one? Sophie, what's 5 times 4? Sophie, what's 4 squared? And 16 times 2? Okay, 32 minus 20 is 12. And then I find f of a, which is 1. That tells me to plug in a 1 everywhere I have an x. Mallory, what's 5 times 1? What's 1 squared? What's 1 times 2? I've got a minus -3. Minus -3. There's your average rate of change. I'm not going to do the next one. It's the exact same thing. It's not any more difficult or easy. Okay. So you guys have to remind me the ones I have to come back and do here in a minute. All right, I have not done 14 yet. What is the maximum height to throw a ball? Adelaide, how do I find the maximum height to throw a ball? What am I looking for? The vertex. How do I find the vertex from standard form? Tanner, how do I find the vertex from standard form? Does anyone remember? It's actually on the board in case you like permanently don't remember. What is it? Yeah, I will not be erasing this stuff, and it's here. From standard form, negative b over 2a will give you the abscess of symmetry or your x. So if you also don't remember, this will be up here. So a, b, c. We start finding this maximum. I'm finding the vertex, negative b over 2a. So negative 60 over 2 times negative 16. Wow, I actually don't know what that is. Did anybody reduce that already? This is what I do if I don't know. Is that it? Well, that's a fun number. Just kidding, it's totally not. All right, now once you find this value, how do we find, that's just my axis of symmetry, right? If I've got this parabola, that's just telling me, here, I need to find that. How do I find my y value? Yes? I'm going to find h of 15/8. Definitely had a typo in here somewhere. It wasn't supposed to be 15/8. But it is, so we're going to find it. Negative 16. 15/8 squared. So fun. Better grab my calculator. I don't think I can just do this one in my head. Even if I'm using a calculator, I do piece by piece by piece. I never type it in from left to right. There's way too many places I can put the wrong thing. So I'm going to do 15 squared. I definitely don't have enough room to do this, though. So this is kind of how I'm going to start doing it. I'm going to see if 16 will go into 64. It does. So I'm going to end up with 225 divided by 4, 56.25. This piece right here is giving me 56.25. This is going to be so messy up here. I am so sorry. So you're welcome to type it in as I do. I'm kind of dividing these out, timesing it by the 15. I got a 112.5. So if you ever look at my answer keys, I know I don't always post them, but you'll see stuff like that and then my final answer. I kind of like that because if you're also going through the pieces, you can see like, oh, I messed up on that piece, right? Okay, then I'm going to add them together. 56.25 plus 112.5 plus 25. So I got a maximum height is 193.75. That's your answer. Did I do something wrong? Oh, is this supposed to be a negative here? Oh, I got to try it again. I got to try it again. I had the wrong thing. Negative 56.25 plus 112.5 plus 25. Thank you for catching that. Okay. I think this is the last one that I had not done on the video. So I'm going to stop the video.